Marty reporting.
Matt at your service.
Shauna signing in.
Amanda here.
RJ's your man.
Holon recognizes Marty, Matt, Shauna, Amanda, and RJ, and Holon is pleased. But Holon reminds you that you are being watched.
We're being watched?
Someone spying on us?
Holon wishes to reveal that it is the others who are watching.
What are we supposed to do?
Holon advises you to protect your privacy. Keep your secrets.
I don't have any secrets.
Oh yeah? What about the time at that party?
Matt?
I'm sure Holon was referring to something more important.
You're right, Shauna. When we pass information back and forth, we'll need to keep it a secret from the others.
How do we do that?
How about a secret language? I way, ont day, e way, alway, ixpay, igpay, atenlay.
I may, istersay, and way, I way, oakspay, it way, alway, ethe, I'm te.
I way, one, it way, ute.
What are you guys saying?
Sounds like a lot of gibberish to me. Hold on, what are they saying?
Holon requests you enter data.
Isthe, isway, igpay, atenlay. Anke, uye, achke, ethe, adernpe.
I see what you're saying, even if my ears can't figure it out. There's a pattern. You're tagging A at the end of a word.
Omthing say igle athe.
No, you're sliding the first consonant sound to the end of the word, then adding A. Vowel sounds stay in front, and A or way is added to the back.
That language can be cracked in seconds. We'll have to do better than that.
We need a tough secret code. And maybe Holon can help. Holon, what do you know about codes?
Your kind has used them for centuries. Holon reveals.
I think I recognize him. He's a Roman general or something.
I think it's Julius Caesar.
He's writing something. But what's that thing he's using?
I don't believe it. You know what it is?
No, I have no idea.
When I was a kid, I saw an ad for a decoder ring. I paid $5 and I was ripped off. But Caesar seems to be working with something just like it.
I still don't know what you're talking about, Matt.
Did you see that?
See what?
Behind the column. Over there. I thought I saw someone.
I didn't see anyone.
Is anyone interested in my decoder ring?
Go on, Matt.
Yeah,
Go
sure.
on, Matt.
Go on.
Well, it worked like this. First, align the alphabet so that A is opposite A. Say you shift it by 3 clicks. Then A lines up with D. 2 more clicks, and A is beside F.
I see where this is going. It's a code based upon a letter shift.
So, if I wanted to code a message, let's say, Matt is my idol, I'd go letter by letter, line up the M and M, then shift by, let's say, 3, and M becomes P. Then,
That'll take forever, and time isn't on our side. Not if the others are watching us.
You're right. Why don't we take Matt's shift code and put it into a table?
Why a table?
Because with a table, we can see the whole shift code spelled out at one time, right in front of us.
The first column is the natural position of the letters, and the second column is the shift 3 position for the code.
That'll make things a lot quicker. Okay, let's get started. How about we code something besides Matt is my idol?
How about Rome? Let's put that into code. R-O-M-E.
okay, with the shift 3 code, Rome becomes Earth.
Hail Caesar, Emperor of Earth. Doesn't quite have the right ring.
I wonder if we could code for burp.
Caesar, Emperor of Burp? Man, that would be funny.
Who laughs at mighty Caesar? You are spies sent by the others.
Others? Oh, no, you've got it all wrong. We were just joking around.
So, you were just making fun of Caesar.
Yeah, just making fun. Well, no, not exactly. We were just making up a code.
A code? I was right. You are spies. Gods!
Wait, I never realized that the mighty Caesar was such a weakling.
RJ, what are you doing?
I got it figured out. Mighty Caesar needs his big, strong guards to handle a pack of kids. Wait till this gets around.
I need no guards. I will crush you myself.
What's he mean by that? Oh, wait a minute, gang. None of this is real. It's all virtual. Holon's projecting it.
You think?
Sure. Why, I can walk right through this wall. Ouch!
Uh-oh.
Hey, Caesar! What's the matter? Too chicken to give us a chance?
You challenge me even here? Well, you have spirit. All right, I'll give you a chance. 5 challenges. Solve them all and you'll go free. Miss one and... Agreed?
Agreed.
Triangles floating in the air, but what 2 things can make them square?
One thing that makes them square is the shape of the patterns the triangles are in.
But Caesar said 2 things make them square. What else?
Let's count the numbers in each shape. 1, 4, 9, 16, 25, and 36.
I got it! This shape has 1 row, 1 column. This has 2 rows, 2 columns, 3 rows, 3 columns, etc.
So?
3 times 3 is 9, and there are 9 triangles here. 4 times 4 is 16, 16 here.
What's your point?
When you multiply a number times itself, you get a square number. Each shape represents a square number.
Good. Time to sharpen your wits. A pattern you have seen before. Find it, open up the door.
Okay, it's a table. So what's the pattern?
Looks like you add 3 to each number.
There's too much missing to be sure.
We don't want to guess wrong.
Let's fill in a few more numbers to check it out.
If we have 1, that changes to 4, and 3, that changes to 6. Then 2 and 5 ought to fit here.
What's next? 4 and 7, then 5 and 8, and 6 and 9.
Well, there is a definite pattern. Take the left-hand column and add 3 each time. See, it checks out here. Add 3 to -1 and you get +2.
I guess another way to describe it would be to say that whatever number you start with on the left, say x, the number on the right will be x plus 3.
So the pattern is x plus 3.
Okay, Caesar, get us out of here. Uh-oh. We must be forgetting something.
Caesar said something like, it's a pattern we had seen before.
But where?
My decoder ring!
What are you talking about?
My decoder ring! Remember when we shifted R to U? We shifted 3 to get the code. That's the same pattern as x changing to x plus 3.
Matt, you are my idol. Woo!
I'm impressed, so I will warn you. The next challenge is much greater. So before you leave this problem behind, gather all the clues you can. They may save you.
What else can we do with this information to gather clues?
You know, the numbers from this table look an awful lot like ordered pairs to me.
If they're ordered pairs, they can be graphed. That might give us more clues.
Here's 1, 4.
4, 7.
3, 6.
-1, +2.
Okay, what do we see?
Well, all the points line up.
And you can extend a line through them.
The line slants upwards.
There are lots of other points we could have put on the table.
What else? The line crosses the y-axis at 3, and that's the same as the constant in our pattern x plus 3. Maybe that means that we add 3.
Matt, is that you? Cut it out, you're scaring me.
That wasn't me.
Didn't they used to feed people to the lions around here?
Okay, what do we see?
Well, we've still got a line.
But it looks steeper.
It doesn't look like the x plus 3 pattern anymore. What do we do?
Maybe we should reverse ourselves.
Huh?
Last time we put the data from the table onto a graph. Now, why don't we put the data from the graph onto a table?
Okay, but we're still missing a lot of points. If x is 0, what goes here?
3,
And for 1?
5.
Okay, can we spot the pattern?
The numbers on the right are bigger like before, but by more than 3. So the pattern isn't x plus 3.
No. But the line still crosses the y-axis at 3. So we still need to add 3, but that's not enough to get this pattern. Maybe we should try subtracting 3.
How will that help?
If we work backwards and subtract the 3, we can see what the number was before 3 was added, and that might give us a clue.
Look! The numbers on the right are twice as big as the numbers in the x column. 1, 2, 2, 4, 3, 6. See?
So we have a pattern. If we multiply the number in the x column by 2 and add the 3 back in, it works. See? 2 times 2 is 4, plus 3 is 7.
2 times 4 is 8. Plus 3 is 11. It checks out.
So our pattern is 2 times x plus 3.
One more pattern you must solve for all your troubles to resolve.
We better snap to it.
Matt, this table looks different. In the others, when the numbers on the left got larger, so did the numbers on the right. But here, the left is going up and the right is going down.
Maybe a graph will help.
Let's connect the points with a line.
Now the line slopes down.
And it crosses the y-axis at 5. I wonder what that means.
In the last 2 challenges, when the line crossed the y-axis at 3, it meant that we added 3. So this may mean 5 is added as part of the pattern.
Why don't we try working backwards again? Let's subtract 5 from each number and see what we get.
Okay, now we get 0, -1, -2, -3, -4, -5, and -6.
I see a pattern. The numbers here are the opposite of the numbers here in the x column.
And to get the opposite of a number, we multiply by -1.
So the pattern must be -1 times x plus 5.
Or we could say 5 minus x.
Or to put it another way, we are out of here.
Holon is pleased you are back safely.
You and me both, buddy boy.
Have you found the answers you sought?
I think so. If we make a code based upon 5 minus x, I bet we'd come up with something the others couldn't crack.
Let's get to work. Table, please.